show. Today is the 18th of March, episode number 40. It's amazing that we're still doing this and adding more and more knowledge to the understanding of Bitcoin. I am here with Stephen. As you can see, both of us, to describe our titles, we are involved with the Scientific Bitcoin Institute. It's an initiative that has as its main goal to study Bitcoin scientifically. Um, we want to be a hub for research that involves understanding Bitcoin deeply, not just as an asset, but as a system. So its social aspects, its economical aspect, its monetary aspect, all these different angles that somebody can understand Bitcoin with. And so, but the goal will be not just to, do posts on social media, even if they have their importance, but actually writing books, articles, to start to approach, the education of Bitcoin with this different angle, saying Bitcoin should be studied as a serious topic. It goes beyond just being kind of like a fashion or a speculative thing. Many people don't take it seriously because of that. And so that is not necessarily, because academia is the ultimate way to show the importance of something, but some is still considered an important force in terms of policy making, or even, let's say, even at least over a long period of time, uh, educating people and making people think about important issues. So this is what is one of the goal of the institute. We are still working on the website. The website will come out soon. Is going to be Scientific Bitcoin Institute altogether.org. So you can go and check. There will be a very interesting website because, first of all, there will be a manifesto. So you can see it's a very well thought. We spend a lot of time describing our vision about Bitcoin according to this particular angle that I just described. But hopefully there will be learning material like videos, lectures, animations, all these kind of different things, because the other thing that the institute will do, it will be some kind of learning institute, right? Educational institute. Would be nice if one day we will be like even kind of beside the research, maybe even like a university. Probably we will start with PhD students that we mentor and work with, and then eventually we can extend the knowledge to all the different level of educations. It depends on our budget, time, and so on, but that will be one of the goals. So we will, as we do these shows, we will let you know the stage of development of all these projects, in particular the website, because it will be kind of a point of reference. I want also to remind that I'm working on a book. It's basically finished. I'm reviewing it. The book is supposed to be available on April 20. You can already go on Amazon and look for Physics of Bitcoin. There is another book called like that, and notice, but it's really 8 pages, and somebody wrote just few things that are not really super interesting or relevant. My book is almost 400 pages now. It's crazy. So you can pre-order it if you're interested. It's really a cool book. Once I finish, maybe I will take the opportunity to introduce some of the chapters and kind of give you a feeling of the things that book covers. I want to finish it first, and then maybe we can talk about that. It could be one of the things I cover in my portion of the Physics of Bitcoin. Okay. Stephen, you want to add anything about the institute or make some comments? We cannot hear you. At least I cannot hear you. Let me check if it is my problem. Hopefully not. No, I can hear other stuff. I cannot hear you.
How about now? Can you hear now?
Okay, perfect.
Okay. I switched
Okay, good.
mics. No, just want to point out that Giovanni is the founder, not just associated, but he's the founder and the director. And I'm proud and happy to be associate director.
Well, we're both founders, so it's just
Yes.
that we have slight different roles. I am the head, but it doesn't matter really.
We have a
Yeah, we are
board.
both founders.
Yeah.
Yeah. Go ahead.
We have a board, so we've got founders, we've got a board, we've got a media director, and we've got somebody, working on the website, and we have our first funding from sources in Europe, venture capital sources.
Yeah.
We're very focused on Bitcoin, so we'll release more information about that later. So we're very excited, and the first work product is a paper that we're going to upload soon, that we jointly authored. Giovanni's first author. We'll upload it first to the archive preprint service and later submit to a journal.
Yeah, and I think we can maybe start to talk about the paper in some of the episodes. Going through the main details, even if they're a little bit technical. Um, Maybe we should first post it on the Los Alamos preprints, and then we can bring it up, and it could be the topic of one of our episodes. Um, and so, it's a lot of initiative. The institute is not like something that we are doing in a garage or something. It's still a small project because we just started, but we started with the right footing. We have a sizable amount of funding. At a certain point, we'll also ask the community contribution. If you want to donate, you want to participate, there will be different level of membership and benefits also. But the entire idea is to have like a point of reference that will be kind of a bastion of knowledge around for Bitcoin. That we will try to do also interact with the media, to educate about Bitcoin. We will try to also interact with politicians. I have direct connections. In fact, I am part of a kind of Italian parliament study group that is studying Bitcoin. Uh, it's very, very little right now, the interest of the Italian politicians towards Bitcoin, but you need to start from somewhere. And so the Institute is actually having a role there in providing advising and knowledge, information, reports. And so eventually we will have a presence in almost anywhere, because I know other people have done similar initiatives in engaging with politics, etc. But it was never like an entire group of people, like a team of experts, bringing, in particular, the scientific angle. Like even issues like it's really Bitcoin plus or negative in terms of energy usage, right? And for some time has been a debate, but now people have written articles, have written studies. It shows that actually it's more a positive force than a negative force. But these things can be measured. This is where science comes about. That we can actually. It's not a matter of opinion. It's a matter of science and data, and so. Anyway, let's move on, and let's introduce the agenda that Stephen is going to share with us.
That's not right. Yeah, there we go. Okay. All right. Number 40. 40 weeks. That's one baby. Although we did have a gap for a couple of months. This is our logo, Scientific Bitcoin Institute, and it evokes both the idea of the atomic structure and science from that angle, and also evokes the idea of networks. And Bitcoin is a network. that lends itself to scientific study. And, this other event, we've just passed 20,000 last week in terms of the quantity and absolute finite supply, which means a completely different type of demand supply curve and different economics. And it's one of the important reasons why Bitcoin manifests power law and scale invariant behavior. So here's the agenda. I want to talk about the persistence of Bitcoin's power law behavior and its structure by looking at it with two techniques. And we've talked about these before about a year ago in this Physics of Bitcoin forum. The Hurst technique is the older one. It dates from the early 1950s, developed by a British hydrologist who was studying the Nile River and the patterns of capture of water in that system. And then a technique that dates from the 1990s called detrended fluctuation analysis that's related to trying to do the same thing, somewhat different results, somewhat different technique, but trying to also look at how much persistence there is in a series, in a financial series or some other series. So a year ago, and I had actually presented this maybe 2 years ago, the first time that I presented some very detailed work. But in a year ago, I showed very quickly that you can actually reproduce this just with monthly results and with a very short conversation with AI. In the latest results, I'm using weekly data over the full history. Now, the important thing is how you look at the residuals. So there's the traditional finance approach that assumes basically returns from one period to the next and looks at how those vary. But what we want to do is look in the context of the power law. Our residuals are relative to the long-term trend, which is a power law. Traditional finance, the residuals are relative to long-term trends, which tend to be compound annual growth or exponential kinds of trends. That's what you see for the Standard & Poor's 500 and for NASDAQ and even gold over very long time periods. So it's a completely different underlying assumption from which you then extract the residuals. And in this presentation today, I'm also going to look at including the log periodic component as well as the power law component. And I'll do that with both the Hurst and the detrended fluctuation analysis, which we're just going to call DFA because it takes too long to say. And in fact, I'm going to close by showing an analysis of strategy stock price with this as well. And that's kind of interesting. Okay. This is not the ECB CBDC, which almost sounds like a musical lesson, but with a 2017 coin, somebody stamped Bitcoin right in the middle. And it's kind of ironic. We expect that Bitcoin will have a longer lifetime and longer persistence than the Euro CBDC, which is under development, and possibly the Euro itself. So we'll see how that turns out. But I'm going to give you evidence for that long persistence. And 2017 is an interesting year because by that time, Bitcoin had locked in very nicely to its scale invariance and its power law, and the index has not changed in any substantial fashion now for the past 9 or 10 years. And that means persistence and rapidly growing value in the market. And that means that it's going to challenge at some point the entire money supply of the European Central Bank, as well as the Federal Reserve. Okay, so this is from a year ago. And somebody posted, recent studies show Bitcoin's Hurst exponent stays around 0.5 on longer time scales and even dips below. There's no evidence supporting H greater than 0.9. They were reacting to my post because I was showing in the chart on the left the work that I had done a year and a half or 2 years ago that shows the rolling Hurst exponent with time. And I had to go down to hourly prices in order to extract all this and get the proper resolution and smoothing. And you can see that the Hurst exponent never dropped below 0.9. And in fact, you have bubbles and you have troughs and so forth, but it always stayed in that range of 0.9 to 1. Now, what is the Hurst exponent? It's a measure of trendiness. If the value comes out to be 0.5, then it's a random walk. If it comes out to be 0, it's highly mean reverting. And if it's above 0.5, and especially if it's above, say, 0.6, then you have trend persistence, and the maximum you expect to see is 1. And the way it's constructed is by changing window sizes within your data series, looking at the maximum range and looking at the standard deviation, taking that ratio. And it turns out when you plot that as a function of window size, you get a power law. That power law is n raised to the h power, the Hurst exponent. And then when you do the best fit, that gives you the measure, whether it be 0.5 or towards 0 or towards 1. So that's the technique. And this is, what we had demonstrated some time ago for Bitcoin. Well, I had to respond to that. And so I did a very quick study a year ago in response. I just gave monthly prices to AI. And this was all of the prompt input that I had to give it. Monthly prices for a 15-year period. I told it that the ages go from 1.5 to 6.5, so it could just interpolate the ages. And I said, convert those to log price and log age, run the quantile median regression, detrend to get log price residuals, and run a Hurst analysis. So what is that? 4 sentences and the monthly price series. So it did that. And I also asked it the question about, well, how should you detrend? Well, if you care about persistence around the long-term adoption curve, which means if you're trying to demonstrate the persistence of that long-term adoption curve, then you want to use power law detrending on log price and estimate H on the residuals with the power law pulled out. And then it also says, you should also look at detrended fluctuation analysis, which we've also done. If you're only looking on a very short horizon, then it says use log differences. But that would be, 1 year or less kind of time scale. That wouldn't be the overall nature of Bitcoin as an asset. Okay, so we give it that prompt. It does the quantile regression on the monthly prices. It says the index is 5.75 for the power law with an error of 0.1. And I did a quantile regression. So it does a pseudo R squared. So the number is a little lower than you get with an ordinary least squares, where you're going to see more like 0.95. And it did both the Hurst R/S and the DFA, and it found 1 for the Hurst, which is the maximal value you can get. So just taking the monthly data, running the Hurst analysis, the graph is one of the 2 larger graphs. It's the upper one is the Hurst. You can see how well the data fits the line, which in this case is just linear because it's log of the RS value against log of the window size. That gives you the slope, which is the exponent is 1.0. It's the maximal kind of persistence that you would expect with this technique. And then the lower one is the DFA analysis. And it fits little polynomials locally to kind of smooth things out. And it gave a value of 1.38. This one gives higher values, but anything above 1.25 is quite strong, and you can get as high as around 1.5. And I'll show you some results like that. So, of course, I sent that out, and then I got this response. It was kind of, okay, we give up. I also broke it between bubble and core, and then you get somewhat different values between the core zone and the bubble, but they're still quite high. They're still like 0.83 in the core and 0.93 in the bubble, which is kind of interesting because there's actually strong persistence in the turbulent bubble zone, and the DFA alpha number is higher as well. Okay, now I just redid this with the latest data up through mid-February and weekly data. So I've run with the different methods. So the TradFi method is the first one in this chart, the week-to-week log returns. And there the Hurst exponent is 0.67. That's very respectable. If you run it on financial data, you're more likely to see in the 0.5 to 0.6 range with this kind of residual extraction. But if you use the power laws and you use ordinary least square fit, you get 0.954. If you do a quantile regression fit, you also get 0.95. And those are reminiscent of the very high R squared numbers that we get in these fits too. They're basically the same kind of 95 percentile. If you take the log periodic signal out as well, so you do a two-stage where you get the residuals from the power law fit, and then you fit the log periodic. And here I use the three modes, which is the fundamental, the first higher harmonic, and the first lower subharmonic, and remove those from the residuals after removing the power law. So 2 stages of residuals. You still get 0.9. So there's still a lot of clear persistence. So, but this also is providing some support for the concept of using log periodicity. These are the charts for DFA with the different methods. So it has a method where it looks at the root mean square fluctuations in a window after doing a small kind of polynomial fit, usually parabolic style. And so you get fluctuations that go like the scale size, which is a window scale, raised to some exponent alpha, and alpha is the score for DFA. So it's the power law index for that technique. And again, in finance, they use period to period residuals. We want to use power law. So if we do use period to period on Bitcoin, we get 0.62 without, using the residuals from the power law. And that's similar to what we saw with the Hurst exponent. If we just take the power law residuals, we get the green line and we get a high alpha of 1.38. So that's very strong persistence. And then if we remove the log periodic wave action as well, and I kind of had 3 different versions of this depending on whether the amplitudes decay, but it didn't matter much. They were all around 1.25 with each of those methods. So the overall picture is one of a Bitcoin price dynamic stack that has the scale invariant power law, and the index there will be 5.7 if you use ordinary least squares, and it'll be 5.8 something if you use quantile regression. And then the next level down is log periodic bubble cycles, particularly the subharmonic, the fundamental, and the harmonic, and with a characteristic log frequency of 2.07, which is kind of a ratio between when you have wave peaks, and it translates into an angular frequency of 8.63 in radians. And then when you take that out, those two are endogenous structure, and the next level down is exogenous, external influences from macro regime. And that can include financial conditions, global liquidity, interest rate spreads, institutional adoption, news events, exchange failing, regulation, everything that's external that can affect things. And once you extract that, then you're left with residual noise and market randomness. And at that level, the noise is quite Gaussian. So here's a commentary on using this combination of scale invariant power law, which is continuous scale invariance, log periodic bubble cycles, which are discrete scale invariance. That combination is common in certain critical systems, including earthquakes, financial crashes, hierarchical fracture models in mechanics. And so you have this form where the first term is the power law, right? Time raised to the power beta. and multiplied by 1 plus an uplift or a downdraft, which is a sum of several modes. And, with 3 modes, it would be the fundamental, the subharmonic, and the first harmonic, but you could add additional modes in your modeling. And then there's an amplitude. So the M is the mode. And when M equals 1, that's the fundamental. And then amplitude sub 1 would be the amplitude for that, and each would have its own amplitude. And then each has this cosine term, which is the periodicity, but it's in log time. And then you have this angular frequency, this characteristic angular frequency, and you just multiply that by the mode parameter. So it may be 0.5, it may be 2 for a higher harmonic. And then each one has its own phase. So it's really a phase sub M for that particular mode. And the reason for all this is that the continuous scale symmetry gets impacted by things out in the environment, which are hierarchical cascades. And my hypothesis is that those cascades are new levels, new tiers of capital. As we get larger and larger tiers of capital entering into the Bitcoin ecosystem, they may resonate with the occurrence of the endogenous log periodic bubble cycles and reinforce them. And then you get an even bigger bubble, or they may, deflate them. But then you break into more discrete sort of scaling. Okay, and you can apply this to strategy. It's not as tight, but it still works, actually. First of all, you fit the power law to the price, and you're just fitting the price since September 1st of 2020. The transition was in mid-August, and this is weekly prices since then. There's obviously a lot of variability, but you have to use the same origin as Bitcoin as your origin date, because this asset is just riding on top of the Bitcoin power law, but it's boosting it. It's providing some leverage. So this is the log 10 of master price against the log 10 of age and years since the Genesis block. And you can see it's a good fit. The R squared is not 0.95. We've got a lot more variability here and other influences. I mean, this is a stock. It's got quarterly announcements and so forth. But it's still a decent R squared of 0.51. And then I fit, after that, a very simple log periodic to the second stage. And so then that's the orange line. And that has an okay R squared of 0.32. I only used the fundamental mode, which is the one with the largest power. And I didn't use any decay in the amplitude of the fundamental mode because things are pretty noisy, so I wanted to keep it simple. But you can get interesting results with the Hurst test and the DFA test. So for master, if you just use the log returns, the TriedFi method, it comes out 0, which is highly reflexive mean reversion in the short term. But if you use the power law residuals, it's 1. It's kind of maximally persistent, very strong trend there. If you use DFA on the returns, you get a higher score. You get a 0.62, the same as we got for Bitcoin, actually. And if you do a DFA on the power law residuals, it's very strong. It's 1.5, 1.6. So again, very strong trend on the residuals. And, generally in line with what we saw with Bitcoin itself in terms of the scoring of how persistent it is. So I guess that's some comfort for people that own master and have had to live through, the very large drawdowns that we've been experiencing recently. But if Bitcoin is bottoming, as it may be now, then so is strategy. Okay, the last is a movie poster. Are you going to show this movie, Giovanni, today?
You can show it. I was going to show it, but yeah, do it.
Yeah. So this is just an advertisement for that.
Yes.
Or a preview. So the one on the left is the one that Giovanni did, and then he can talk about. And I thought, well, this is intriguing. So I thought, can I reproduce it? And I was able to fairly quickly reproduce it. That blue line is just the power law index, and it shows how by log 10 age of 0.7 or 0.8, which is about age 6, it's flattening out nicely and converging on the present day result of 5.7 for this regression. So that's what I have today. Thank you for listening.
Thank you. Very wonderful. Yeah. Yeah. I mean, if you do a DFA without taking out the power law, you're defeating the purpose because basically you are detrending the power law. So it's better that you do the other way around, like you did. You're trying to account for it, and then you're detrending whatever is left over. That is kind of what you did, right?
Yes.
Right. And it's very interesting. That measure actually is a very cool measure because at a certain point, for example, I was working, I got, well, I knew it, but I never used it in a professional setting. And then I was working at Northwestern in this lab that was interested both in the neuroscience of sleep, but also circadian rhythms. And there was this professor of physics. Of course, he had to be a physicist, Professor Who, that I think he did most fascinating study in human circadian rhythm. And very few people know about this because I don't know. I mean, he came up with these unbelievable, interesting, fascinating results. And then the people in the field or ignore it or they don't understand it, in particular the biomedical field, because that was my experience. I write about this in the book that they don't understand non-linearity. They don't understand the scaling arguments and so on. But what the guy did, he looked at human motion, like a Fitbit that everybody has, but instead of looking, usually Fitbit gives you something that is okay, but not very deep. That is how many steps you did in a day, right? How many? It's useful, gives you some point of reference. Maybe it motivates you to reach a goal, do certain number of steps, but it doesn't give you any deep information. So he actually looked at the raw data, and he found out if you do a DFA of the data, so the trended fluctuation analysis, but basically is looking at the fluctuation at all the different scales. So these scaling arguments, right? That the healthy people had a DFA that was close to 1. And actually that was something, so that you could classify the different type of noise, like Brownian noise, pink noise, white noise, using this DFA, and they have different value. And the human healthy way of walking and moving is in between order and disorder, like kind of an edge between two. That is what Bitcoin is, right? Bitcoin is exactly in this edge between order and disorder, and that is where human health is. People have also studied the art, for example. The art also behave in this scaling variant way, where it looks regular, but if you look at the variation in this regularity, it needs to be on this edge between order and disorder. If it is too orderly that you think is a good thing, actually it's not. For many biological system, it's not, because they are. It's like robots, right? When robots are learning not to be like that, right? To robotic, and they need to be adapted and respond very quickly to different situations. And so this guy was able to show the different DFA for different situations, different ages, for example, and they show that is a very powerful biological age marker. So it doesn't depend. You can take two different people with different type of lifestyles, and you can discriminate them. You can looking at the DFA, and then it show that people that have Alzheimer, in terms of DFA, they look basically like white noise. It's really basically they are dead. They are alive biologically, but their brain is noise. It's just noise, and so they are, even their motion is basically just like noise. We move like in a very noisy way without purpose. It's a really, really fascinating study, and it shows how these ideas, they can be used to study anything. And we are one of a few people that does these studies on Bitcoin. Showing using these techniques that have very important applications in many other fields.
And it's exactly this value. When alpha is one. Um, that's what pink noise. That's 1 over frequency noise.
Yeah, yeah, it's power
And
law
when
noise.
alpha is 1.5, it's Brownian random walk.
Yeah,
And what we're finding is in between, about 1.25, 1.3,
yeah,
which is exactly this kind of edge of chaos. Now, it's not exactly chaos, but people talk in those terms,
yeah,
right? That, and both the brain and the heart manifest that kind of behavior, right?
right, exactly,
Yeah.
exactly.
So,
And so, yeah, it's very interesting. We are measuring the health of Bitcoin, and it's a very healthy system. It's very, very fascinating. Anyway, so I have a few things to talk about. So I'm going to show my slides. The first thing, I think I already, well, let me go back in general. And I want to start with this slide. Let's see if I can do a slideshow from current slide. Okay. And it should look like much better, right? Yes, much larger. So what this slide is about is I want to bring, maybe I mentioned it last time. I want to bring it back. I made an entire video. And again, this is not polemical because we are trying to be scientific. We are not trying to make it personal. But part of what we are doing here is also educating people, right? And so people are getting a lot of information. I'm not sure. Maybe I'm taking too seriously, how people interact with different analysts online, and maybe people simply like something because they see a nice graph, it's colorful. Like for example, the graph that I will show you next received more than 1,000 likes. That is like one of my records uh, because it's beautiful. But I don't know how many people really dwelt in the meaning of it. It's both beautiful and meaningful. But a lot of people maybe like stuff online because I don't know, they like the graph, they like what the colors of the graph or whatever, and they don't spend too much time in thinking what is going on. And there are a couple of influencers that have a large following, and so this is why I even mentioned this, that are giving the wrong message. For example, one of them is Plan C, but now he has this new series of posts where he's insisting that there is something wrong with the power law and it needs to be fixed. And I can assure you, because I'm sure there are some people that follow him and some people that follow us, that you can do all kind of tests. And Stephen has done this test, and other people have done this test, showing that there is nothing wrong with the power law. The power law doesn't need fixing. It's very stable. In fact, any type of test that you can do, it will show that. Like even his test, what Plan C claims, that he's saying, so he has a couple of arguments. One is saying that we should not use the least square. No, it's not true. The least square is just one of the many methods that you can use. It's not the definitive method, it's not the only method, but it's one of the methods. It's least square means basically you're trying to reduce the square of the distance of the points from all the different points from this line that you want to find. You want to find the slope and the y-intercept of this line, right? There are limitations, in particular, if you are dealing with something that has long, big tails, that has events that are really large. So there are other methods that you can use, that we have used. You can use Bayesian regression. You can use robust forms of a least squares that is giving less importance to outliers. You can use, in my book, for example, I mentioned 5 or 6 of these methods. And you can never say, if you know what you're talking about, this method is better than this other one. No, they have limitations, all of them. And it's almost like I did this example when you go to the doctor and the doctor says we should do a blood test, we should do an MRI, we should do all these different battery of tests to get a whole picture of a individual. So, and now there is no doctor that say, oh, the ultimate test is the blood test. No, the blood test give you an information, the X-rays give you another, the MRI gives you something else. So you want to have as much information possible. And when you put all this information, all these different methods, what is extraordinary is not that a method, like for example, Plancy say, shows you that you will get exponent that is 2.5%, because this was his conclusion, that using this method, the difference was 2.5%. That is, anybody that knows these things realize the noise that we are dealing is much bigger than this correction. So he's proposing a correction to the power law that is much smaller than the implied noise that we are dealing with. That is like a rookie mistake. And again, I'm not trying to make it personal. I'm trying just to show people how to be discriminant when you're looking at this information online. Because some people, not because me and Steven have PhDs, it's also because of that, because many years working on these things, 35 years, you know, we did this mistake when we were students, and then we overcome because we had people that taught us, you know, how to deal with these things. We applied our experience. We published paper with, we got, you know, slaps in the face because we were doing mistake, and maybe the peer reviewer told us, oh, this is nonsense. And so we had to learn how to deal with what is true and what is not, you know. And it's great. I am the first one to say people should go and verify and reproduce this result and study, because with AI, you know, we are going back almost to the beginning of science, when a lot of scientists were amateurs, were citizen scientists. But, you know, being amateurs doesn't mean that you can be sloppy. You have to be very, very precise in what you're saying. You have to, you know, and in particular, I think there is a very strong reason to deviate, you know, to make posts that are sensational. Oh, the power law needs fixing because it's broken, you know, and you will get a lot of people attention, because there are some people that don't like math, or they don't like even this idea that Bitcoin follow a very precise pattern. You know, they are against it because they will like Bitcoin to explode and go to whatever value. So if you tell them that power law is broken, they will listen, you know. So no, it's not broken. So let me repeat, it's actually, you can do a lot of tests. This one test that I did, there are many others. What I did here, I kind of going to repeat a little bit what I said last time. I look at the dynamics that, again, for example, I think is a much better way than looking at these lines, you know, the regression lines, because the regression lines come up, you know, it's just one of a way. Like I say, it's one test, right? So they come up with this Bitcoin value, you know, reference value. It is a useful thing, but actually, I don't think it's the best way of showing why the power law is so relevant and important. It's more about how we go there than where we are at any point in the um, in the price. Because we could be, for example, where we are right now is different from where the reference line is, but we are still moving according to the power law. If you're looking at the dynamic, if you're looking at the price change, for dynamic, I mean how the price change. It is a much more physical way of looking at things, because we are more interested in how an object moves and how it changes velocity, and how it goes there, so the dynamic, than where it is in a particular place. So focusing on the regression line and say, well, it will bend a little bit if I use this exponent versus another, is the wrong point of view. Is how things change. So if you're looking at this quantity that I call the normalized returns, so I take the change in the price as a ratio, and then I normalize it by the decay with these these returns are supposed to have according to the power law, you get a very stable quantity. And you can see I did this stability test with this, basically plotting this exponent. Turns out that they are both returns, so they describe the dynamics of the changes, but also they are the slope, the log slope. That is basically what Stephen was showing in that graph. And I will show you also an animation in a moment of these graphs. If you're looking how these slopes are changing over time, they oscillate, they change because there is noise and there is, there is variability and volatility. But you can see here, I'm plotting these changes, right? It will look like a bunch of dots at the beginning. Well, first of all, the dots, you can see they are equally below and above this line that is the same line that you get with regression. So the value is 5.9, right? So we are both above and below that reference value of a slope. And then if you do a moving average, so your average over a certain window, the value of these slopes, you can see that it's just a quantity that is oscillating from the early days. That is the most amazing thing, because if you're looking at regression and you have used only the first few hundred days, you will not be able to see the power law, or you can think the power law, but it will be a very different power law than what we get right now, because there are these huge big bubble that dominate the data and that show the limitation of regression. This method doesn't rely on regression. It calculates these changes in the price, and they reveal the power law, because the power law is there. The oscillations are around this fixed value. And you can do it, what this graph shows is doing it at the daily level. So you can calculate these changes daily. You can calculate the changes monthly. You can calculate the changes yearly. That is the last graph. And you can see it's always the same result. You get the same result. That is another way of looking and studying scales when you're looking something on many different temporal scales. You're looking at days, you're looking at months, you're looking at year, same picture. The power law, it's super stable. I mean, it's something so extraordinary that every financial person should talk about. It's an example of something that is so stable in the financial world that I don't think we have any other example in the history of finance. Okay, so it's a stable quantity. It exists. It's not changing, and we will be the first one to tell you, oh, look, something is wrong or something is different, because it's an historical fact. I mean, even if in the future and changes, it doesn't change the fact that historically Bitcoin for 15 years, 16 years has been a power law. If it doesn't do that in the future, well, it's actually useful that we study this, because we can compare the past and the future. This is how you do science. You also models are also useful when are broken. It's not that above it's broken and they're throwing it away. I'm going to use it to check what is different, and maybe if a model can modify it to include these changes. These are how you do science. But right now there is no need for that. Okay, unless you have a personal agenda and you want to show your relevance, and you want to show that you're doing something better than anybody else, when there is no need, because it's not about you versus others, it's about truth. So the truth is Bitcoin power law is stronger than ever, it's not changing, and we will let you know if it changes. I don't know if Steve wants to comment about this and say something. Does the Bitcoin power law needs to be modified or fixed right now?
I want to show a graph.
Sure.
If I may.
Let me do, absolutely. I will stop sharing and you can go ahead.
If I can find the right. This one.
Okay.
Can you see that?
Just a second. I need to add it.
Okay.
Yeah, go ahead.
Okay. So I did this in December, Christmas Eve, 2024. So this was my response to this criticism about autocorrelation. The prices are autocorrelated. Well, if you shoot up a rocket, the position of the rocket is autocorrelated, right? Where it goes next depends on where it just was. And yet it's following the laws of physics. There's a little bit of buffeting from the atmosphere, a little bit of mechanical vibration, but it's following a trajectory determined by the rocket equation and by the gravity of the Earth, etc. So, of course, the positions are autocorrelated. So if Bitcoin is pursuing a power law, it will be an autocorrelated. Now, there's a way that you can test and correct for that, and that's what I did here. This green line, FGLS, is generalized least squares, and I did it to both first and second order. And there's something called the Durbin-Watson statistic that tests for autocorrelation. And this technique eliminates that. And after I did that, the Durbin-Watson statistic was 1.75, which is very close to the ideal value of 2, where you've eliminated most of the autocorrelation issues. And what you can see is it's a very good power law.
And let me say about this. Okay, this is how science works. You find first we using the simplest possible method. In fact, what is the simplest possible method? Not even this curve, just your eyes. Take out all the curves. You see a straight line. If you are trained, I see a straight line because these oscillations don't matter. This is how I recognize the power law in the first place. I'm so used to see these power laws that if I take the data on many scales of magnitude and it looks straight like that, publishable paper. Okay, it's obvious. It's obvious. I don't know how to explain it to you. It's obvious. Now you can do then the next thing. Let me do least square because it's the simplest possible method, and you do it. Is it useless? No, it's very useful. And then you come up with somebody. When you get worried and you say, okay, can I do it in a more robust way? This is the word that you use. You can do it, for example, by taking out the bubbles. There are methods that are scientifically valid to where you take a certain level of outliers and you call the bubbles outliers. You can see with your eyes that the bottom itself, right, form a power law. If you take out that, I showed people, and all of us have done this exercise. If you take out the bubble and you connect the dots, it's almost scary how straight these points are. It's scary. Okay,
Mhm.
it's people see that and say, okay, wow, I didn't realize that. We have graph for that. The next thing you can do is say, okay, let me use these other methods that are a little bit more sophisticated. You continue. And anything you do, all these X-rays, MRI, blood tests, they show the same picture. Okay, these variation in that slope are nothing from a physics point of view, are nothing.
Right.
Now, if you are really want to go deeper, people can go and say, okay, I should use this method versus that. And that is a valid contribution. It's not a waste of time. But you see, it will be different if people like Plancy will say, listen, I went deeper, I used this method, I found out that it can be correct. It will be a valid contribution. It will add to our understanding, knowledge of Bitcoin. And it should be celebrated like that. And, you should get the credit. But if you start to say, hey guys, I found out, imagine somebody publish a paper and say, hey, Mount Everest is 8,235 meters, right? Because that is what your instruments say. And then somebody say, well, it's not true. So 8,237, like something ridiculous, like 2.5%. Okay, you could even publish that, but nobody will say that is an extraordinary discovery and changes radically our understanding of Mount Everest. It doesn't. Okay, so this stuff needs to niche, and we will continue to point out. I know it sounds very polemical, it sounds very personal, but we need to set up the record straight, right? And part of what we are doing is to educate the people about this. And it's not because we want to gatekeep things. There are people that are doing this contribution in the right way, and I celebrate them all the time. I praise them because it adds to the knowledge. If you do it where you're saying things that because you talk with ChatGPT and ChatGPT, all the eyes tend to kind of agree with what you're saying, and they say, yeah, this is important to point out, etc. This is a big contribution. Yeah, but it will end eventually if you don't know what to ask and how to ask to agree with you. Okay, almost like I saw conversation of people saying the craziest things, and the eye tends eventually to agree with you. Okay, you need to use like all the tools in the correct way. Uh, so and this is why some level of discrimination by people that have years and years of experience and don't need to ask ChatGPT, what are all the possible methods of regression because you never studied them, because we know what are and how they are used. You know, yeah, it makes a difference. It does make a difference, and particularly if a message is distorted, because what happens. You say the power law is broken, etc. Many people will be confused, and because the power law is such an important and a tool to understand Bitcoin, we don't want to confuse the message, right? We don't want. So this is why I'm pointing out this. Anyway, so let me continue in my discussion. and some of the things that I explored recently. So this is a very powerful test. It shows, you can do it even in a more sophisticated way. For example, you can see these values are distributed, right? And you can fit the distribution. When you can fit the distribution on a moving window, you can look every time. You don't even need to look just at the past because it's not a predictor. You could do it in a center way because you're trying to describe the structure of what you are describing. And so if you do this moving distribution, so basically you're not just looking at the mean, but also how much the value changes over time, how big the tails are of this distribution. You can do tests to compare this distribution, though not just the mean, but also the statistical behavior of these slopes change in time. And you can do this test, and the tests say, no, they don't change. They are stable. Of course, we change momentarily day by day, but when you look at bigger scale of time, they are stable. It's stable. So that is the message. That is the true scientific message. Anybody else saying the contrary, they don't know what they are doing. And this is true. There is a consensus among people that have you know the formation and the knowledge to discuss these things. And you can do it yourself. And then if you have an argument, bring the argument, but it needs to be a valid argument. Anyway, so let me go ahead and show you the next slide. So the next slide is this one. So I think I showed you this before, but it's a beautiful graph. It basically describes the same thing in different way. So here, what I'm doing, I'm taking these changes. I don't normalize them. I take the changes in price. So what you're seeing on the x-axis are the change in price. So price today. In fact, actually, I'm sampling. Right. This also solves some of the criticism, if there are criticism, or some of the things that somebody like Plan B says is wrong with what we're doing, because I'm testing the power law at different scales. I'm looking at all possible. So basically, how it works: you take 2 random days, and then you're looking at changing price of these 2 random days. You're plotting it as a log on the y-axis, and then on the x-axis, you're plotting the change in time. So basically, it's almost like you're measuring the scale of the time, right? How time change between these 2 points, random points. So there is no assumption. You see, I'm not fitting a line. Eventually, I fit a line, but in the constructions of this diagram, there is no any assumption. I'm simply taking two quantities. I do it over and over again. It is a very physics-like to do. It's like almost like you're doing an experiment over and over and over and over again, and then you're seeing the average behavior. And you can see immediately how the graph for Bitcoin is so different from NASDAQ, SP 500, gold, or anything else. With all this stuff, you can see there is some kind of a S shape, right? That indicates that there is not a scaling behavior, that there are different regimes, there are these kind of wings, almost these saturation effects, actually something that would be interesting to characterize better why you get these if you're doing it. By the way, what I did also is not shown here. I created a synthesized power laws and synthesized exponentials, and you get exactly the shapes. You can reconstruct the shapes by using synthetic data, because that is another thing that we will do in physics. We start with something that you understand, like something that you created. Like I'm going to use a power law. If it is a perfect power law, you just get a straight line, but you add some noise. Right? You can add additive noise. You can use multiplicative noise, and then what is your input. So you can compare what you know with what you don't know and get exactly the shapes for a power law, and you get the same shapes that you're observing for exponentials. And so I think actually this is a novel method that is probably publishable. Me and Steven will publish and try to characterize and see how we can, you could give this, for example, an artificial intelligence, because artificial intelligence use methods like this and say, hey, given this as a pattern, discriminate between scale invariant system and non-scale invariant systems, and the AI will be able to pick and differentiate. So this was a post that got thousands and thousands of like. I was even surprised, maybe because they are very colorful and beautiful, but it's very striking to see how different they are, different beasts, different universes. Anyway, and then I have this animation. So this is another way of showing the same thing, but right now, you see this previous graph was showing both the positive and negative value, because the negative value will be when the first day is smaller than the second day. So basically, almost like you're going back in time. And here you're basically looking at the gain, and here you're looking, if I go back, it's basically, it should be symmetric, and it is, right? You can go in both directions. That is another property of Bitcoin, because Bitcoin, see, power laws are also, it's like a sequence, a story that goes deeper and deeper. Like you can go to the inside the rabbit hole more and more. Like, for example, power laws, because they are related to scale invariance. In fact, is the only function that is scale invariant. Is also related to symmetries. So symmetry means, it's kind of the definition of scale invariance, when something is similar to itself. And you can see a straight line, it's similar to itself, right? I can take any chunk of a line, it's similar to the rest of the line. And this, because we are talking about time being in the x-axis, means symmetry in time. So you can go, basically means Bitcoin in this strange space of logarithms, so it means in the space of scales, it's similar to itself in time, what is called time translation. So if you go forward in time, or if you go backward in time, Bitcoin is similar to itself. It doesn't change. It has a lot of consequences, because it means it's stable. It means that Bitcoin doesn't need to do anything special to continue to go up. It just needs to be itself. If nothing changes, everything remains the same. If all the process, all the mechanism that is producing the power law continue to be there, Bitcoin will continue to move up along the power law. It will take some time, but we will reach 1 million and then 10 million and so on. See how consequential this idea is. It's not just some random idea. It means that Bitcoin needs to do simply what it's doing right now to go where we would like him to be, right? 1 million, 10 million, and so on. So it's a very powerful, deep understanding of what Bitcoin is and its properties. And so this other graph shows kind of a similar thing, but I'm doing it only with the positive changes. And then what I did also, I kind of binned all these values in the t-axis. And when you do that, and when you're trying to fit these, you get something even more extraordinary. That is basically you get one. You're close to one in terms of how correlated this thing is, in terms of how known due to chance this thing is. It's basically impossible. And again, you can see the striking difference with everything else. All right, and then here is the graph that Stephen was showing. It has music, so if you go, eventually we will post maybe a more polished version on the scientific website, Scientific Bitcoin Institute. But it's basically a movie of what Stephen was showing, that are these slopes. So let me repeat. Okay, let me go a little bit further. I will stop so you can understand. Okay. Oh, I don't know. Maybe I should not stop it. I will not stop it, and because I think if I stop it, there are some problems. So maybe it's interfering with. Let me see if I can do this. Maybe if I do this, I can stop it. Yeah, I can stop it. And you are still seeing, right? Yeah. Let me close these just to get. Okay. I will do it here, and then maybe we can watch it one more time in slide presentation. But first, let me explain what you're going to watch. Okay. So what you're going to watch are these lines, red and green lines, what they represent. So basically are these. So imagine I calculate the change in the price, right? So price today over price yesterday. And then I divide it, and you can go through the math, it's not very difficult, by the change in time. If you follow the math, that should give us this n exponent of the power law, basically the slope, that yellow curve. The yellow curve is calculated through this method of regression. It tends to draw a line in the center because that is what regression does. It tries to find a compromise. It's showing, well, this thing is oscillating up and down, but overall is oscillating around this path, this straight line path. Now, what you're doing is something where we are measuring the change, because remember, actually, the change in a power law, if anybody did calculus, is also a power law, right? So we are calculating these changes. We are normalizing by this factor that is a change in time. It should give us n. It should give us the slope. But we are doing it even far away from that line. We are doing it when we are in the peaks. We are going to do it in the bottom. Like when you're doing on a peak, you're it's a peak because we deviated from the power law. So all these slopes are much higher. They have a much higher value than the average slope, because this is, so imagine almost like a wind, right? So imagine there is a vessel that is moving towards a particular direction because this is where you want to go, and there are people inside. They are maneuvering, right? There is some intelligence. There is some wheel of going in a certain direction, right? But then there are these winds, and the winds sometimes they push towards northwest, and let's say north is up, right? They are in general, these winds in average also that is another analogy. We could say there is some general wind that push us towards northeast, right? But sometimes the push is much stronger towards the north, and so the vessels is going to move more towards the north, right? And very fast, because there is also an average velocity for this wind, and the wind sometimes is faster, so it's moving you much faster up, and other times it is the north, and then other times is moving you south, and so this shows how basically the strength and direction of these little lines that you're going to see, little arrows, is the direction and strength. Bigger the line is, stronger the wind, and is also showing the direction, right? In this, which direction the line is pointing. These things have a name in physics. We call them vectors. Vectors are quantities that are a little bit more complicated than a number, because a number has only the size. It's called a scalar. Right? Many quantities are scalar in physics, like temperature, for example, the volume of an object. It doesn't have any direction. And then there are things like velocity, force, but they have both size and direction. So we are showing here the vectors of these price changes, right? And what the video is trying to demonstrate, that if you take an average over the long term, so you are going to see two things. You are going to see the blue line, that is the total result, is the cumulative. So I'm adding more information. And what you are expecting, if a power law has a dynamical process, or as the wind that pushes things in a certain direction is real, that blue line should stabilize. It should be, doesn't matter where it is along the path, it should become more and more parallel. Then I don't change the total size, because if we did, you will see bigger and bigger and bigger. But we are just looking at the direction, right? So the direction of this blue line should be more and more parallel to the yellow line. The white line is going to change. It's not going to change as much as a very local. So the lines, red and white, and the convention is red when we are going south, green when we are going north, right? But these are daily, so it's basically you're measuring the wind for that day. The white is measuring the wind, the direction of the wind in 1 year. It is a little bit more stable, so it's not going to fluctuate crazily like these little lines are. It's going to fluctuate much more slowly and smoothly, but it's going to fluctuate because you are going to still be susceptible to the different oscillations of the bubbles, right? But that blue line is going to be stable. So I think I explained basically everything relevant to the graph. So let's see. I'm going to go uh, to the slideshow and then run it. Okay, so you can see the movie. The movie is trying to explain what you're watching. So you see, it's oscillating. The white line is oscillating a lot. The blue line is becoming more and more stable. And right now, you can see also on the right the values. Right, it's giving you the total value. Notice how beta, the slope, the blue one is stabilizing. It's becoming, the changes are smaller and smaller. So you see the wind is pushing in every direction possible, but the average direction is one. We are going up, 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 up. Northeast. Yeah. So I think it's a very fascinating movie. I think it's actually one of the best visualization that I ever done. Um, it, of course, I have done it with AI. But, I told it exactly what I wanted and how I wanted, and it did it. It will have I could have coded it, but it will have taken me probably many hours before doing something like this, and the AI did it in few seconds. It was just unbelievable. But it's conveying the information, and you can see that the end result, it's that slope that we find. It's basically, you can see by I2 is parallel to the yellow line, and it has been parallel for a long time. After some time, even during the bubble, you can see during the bubble, sometime it got pushed all the way to 7, but it goes back. It goes back to that original value, to that average value. So I think the analogy of the wind is one of the most powerful one. You can think of the magnetic fields. You record, if you ever play with, if you were in a physics lab and you put a magnet and then a piece of paper and you sprinkle some iron filing, you can see all the field lines. We call them field lines. They show the direction of a magnetic field. So it's a very powerful physics analogy for this, and I find it so beautiful that at any particular point, the price is pushed in many different directions, but the total result is the power law. I mean, if you don't find this deep and beautiful and fascinating, I don't know. Something is wrong. I think it's amazing. It should be like viral. This thing should go everywhere. Every major Bitcoin influencer should show this. But it got some likes, but I think many people don't get it. They don't understand it. They don't know, and it doesn't matter how well you explain it. But part of what we are doing is this. We will continue. We'll try to educate people, try to diffuse the message as much as we can. And you guys can also in the comments or DM me and let me know what is the obstacle. What is the problem in understanding. Today, somebody was telling me something about scientific notation. Because in my old graph, I used to show a scientific notation, and that was a stumbling block for some people. But here it doesn't even use standard notation. I mean, it doesn't use scientific notation. It use dollars. So I don't understand. I don't know. That should be something that maybe we study. What stops people in understanding the power law? Do you have any clue, Stephen? Why so hard?
Well, I think it is fear of math. Their eyes glaze over once you get past multiplication and division and percentage compound
Yeah,
growth, which the financial world keeps drumming into your head: percentage growth, financial growth, compound growth. So
yeah.
everybody's comfortable with that. Inflation, right? GDP
Uh-huh.
growth. They live in that world, and so they are brainwashed that is everything. and it is not everything. Gravity is a power law. Electromagnetics is a power law. The fundamental forces of nature are power laws.
Right.
But they're not living on that plane. They're living in the linear approximation where they're looking over a very small dynamic scale, 1 year to the next. What's the percentage growth for the money supply, the GDP? What's the interest rate? It's all small numbers. It's all short domains. And we're
Right.
thinking in powers of 10 and another power of 10. I don't know if anyone's ever seen these movies, powers of 10. My undergraduate thesis advisor was the narrator for the original Powers of
Oh,
10 movie,
wow.
which was in black and white. And it starts with a girl sitting at a picnic, lying on a blanket or something, and it zooms out order of magnitude, order of magnitude.
Yeah.
You go through the Earth's atmosphere, and you get past the moon, and you get to the nearest star, and then you get out, to the edge of the Milky Way, and then more galaxies, the edge of the local group, and out into the domain of clusters and superclusters and the scale, the cosmological scale at large, which is a visible sphere 47 billion light years across. So, as physicists and astrophysicists, we're used to thinking in these terms of an order of magnitude and another order of magnitude and another order of magnitude. Bitcoin is the only thing around that has moved 7.5 orders of magnitude in a 16, 17-year time period. Nothing else has moved that far.
Mhm.
And so you have to think all in logarithms first, right? And it's just people aren't used to that. And our minds tend to linearize things because it's just easier to operate that way.
Yeah, absolutely, absolutely. Okay, we can go through some of these questions. What do you think? What do you guys think Bitcoin bottom? To be honest, it's interesting, and it's one of the things that we can try to answer. Whatever one of the, if you want to stay in the language of the power law, we have this thing called the Bitcoin power law bottom. It's not something, I always say, it's not really the most important or even interesting component of a power law. It's just an added bonus that it seems that has never been violated. We came very close to that bottom recently, but we didn't touch it. It was more like 55K, and we didn't go there. Um, we are recovering and going up. It could be that this was the bottom, and
Mm-hmm.
we are going up, from here. And Apple are, it's very different. And I will be dishonest if I didn't say I'm also influenced by that, right? Because I would like, we like more when Bitcoin goes up and down, right? But I still want to say that in general, that is not what we are trying to emphasize here. We are, yes, it's, like Steven, for example, makes these long-term models of the oscillations, using low periodic model, and it's an exercise, but it's an additional exercise. It's like one, you're going a little bit deeper, and you say, okay, beside these long-term trends, there are also these oscillations, and they have a meaning, and blah blah blah. It's interesting, but if you have to get one single message from what we are saying, is that in the end it doesn't matter. You see, it's basically this picture that I just showed that matters. That is the essence of understanding Bitcoin. That it doesn't matter where the winds blow. In average, you are still moving in the same direction, in that direction. And we have done it for 16 years, and the wind went up like crazy towards the north, the wind went down like crazy towards the south. In the end, the average result is moving to the left, to the right, up. Right. So if you are really focused on looking at Bitcoin in the long term, that I think every Bitcoin should, because for us it's a long-term investment, you should not care. We should not care where it is. You know, I don't know if you want to say something about that, Stephen. Steven? Yeah, Steven got frozen, I think.
Yes. Can you hear me?
Oh, yeah. You were so quiet that I thought for a moment you got
I'm
frozen.
having issues.
Okay. Yeah. You
How
want to
about
say
now?
something about it? Yeah. Perfect.
How about now?
Yeah. Great. We can hear you. Go ahead, Steven. Go ahead. Okay. I think we have a problem with
The,
us. Yeah.
the yeah, the trough in 2022 bottomed in the 15,000 to 16,000, and somebody asked me yesterday on X, is this similar to that, 60K or so? And I did the calculation. You would expect to be up by 3.5 times, and that puts you in that 55, 60K range. So it's certainly plausible at the bottom, and we have a slightly steeper index if you do quantile regressions, down at the 10%, 5% level. I think 60K, we touched, and I think there's a good chance that was the bottom. Looking at conditions, we've obviously got very uncertain geopolitical environment, so we'll have to see.
Okay. Yeah. Just curious. I have found any other power laws in crypto, AI, and how did you discover the power law and so on? Well, first of all, you should read the book because the first few chapters is all about how I came up with the discovery. So go and look for the physics of Bitcoin book. But yeah, no, Bitcoin seems to be the only crypto. And you will say, well, there are not all the things you're saying that are causing the power law, being a network, etc. Well, the network needs to be big enough, established enough, needs to scale enough, and the only network that has done that is Bitcoin. Even Ethereum, and not just that. Again, read the book because, and actually, you make me think. I don't really address very quickly why Bitcoin follows the power law while other crypto don't, because every time I'm thinking about stuff that I didn't include in the book gets 20 pages more, and it's already 400 pages. Maybe we need to write a second book where we address a bunch of questions or we go deeper or whatever. But yeah, no, because for example, with Ethereum also they did the mistake of shifting from proof of work to proof of stake. And it's one of the things we say in the book, that the proof of work gives you one more level of feedback that creates these power laws, while proof of stake not. And so, there are many reasons why other cryptos are, but it's easy to demonstrate. You just do whatever you did with Bitcoin and they don't show a power law. Some people have used it against it, the power law idea. I don't see how. It's actually confirming that Bitcoin is different even for other cryptos. It's like the resistance is so big that I even saw some Bitcoiner influencers say, "Oh, because it doesn't apply to the other crypto, so maybe it's a spurious thing." No, it's the other way around, right? Actually, it shows how different Bitcoin is, even among other cryptos. And I don't know if you're asking if AI is something that shows up, power laws showed up in AI, and I have an example, or you're talking about AI stocks. I didn't look at AI stocks. I expect the only place where power laws appear related to stock is sales. So there are articles that show that if you look at the sales of many different social platforms, the sales of advertising, it's a power law in users. So basically Metcalfe law. So that is actually demonstrated with the sales. The stock value is different because the mechanism that determine how people price stocks is different than these network effect don't show up, but they show up with Bitcoin. And the reason is because we determine the price by things like this, even just watching videos like this or participate in the community. All the interactions that we have in the network determine the price. How it's done in all the details is something that one day maybe we can model, but it's very clear. It's very clear that Bitcoin price itself as if it was a network, while all the other assets don't. AI has a power law in it that is basically, um, in fact, we talk as often about scaling. So basically, the level of computation that is needed to bring AI to the next level, it's a power law. It's a scaling process. So how many, um, how much computational power you have to use, how many connections in the network. So basically, it's a network too, right? AI is this neural network. So many nodes, so many connections they have. It's all a scaling kind of process, and so power laws show up there. And maybe Stephen knows about this topic even better than me. Do power laws show up in AI progression?
Well, not in the progression of the power of the models. Those have been growing super exponentially.
Mhm.
And I did do an analysis of the NVIDIA stock price and its compound annual growth. It's an exponential. It's around 68% compounded. And exponentials are unstable. You cannot grow an exponential curve for all that long. And I can demonstrate that NVIDIA cannot grow in that same 68% exponential for another decade, because if it did, it would be equal to half of the total wealth around the globe. So what cannot happen won't happen. It's going to have to flatten. And that's one of the things about the power law is it's more stable. It's just more stable as a structure because it doesn't grow crazily. It grows in an ordered, controlled manner because it defines its own structure. We call this autopoiesis.
Yeah. So yeah, the power law, I was just checking using AI. It's this neural scaling that I was mentioning. Maybe I didn't express myself. So basically, and I can show you in a graph, is the error that these models have in proportion to their size. This is why we make them bigger and bigger and bigger and bigger, right? Because actually that makes more powerful, more precise, and so on. So it's a power law scaling. Um, so the loss of a system is inversely proportional to
The error is an inverse power law, right? So what you're
yeah,
saying?
the error
Yeah,
is inverse power
that
law.
makes
Yeah,
sense. That makes sense.
yeah, yeah. And this is the scaling problem that often they mention. So now, how they are solving the scaling problem, it is an exponential. We are doing it faster and faster and faster, but there is kind of a barrier that is this scaling. And that in fact has never been violated so far. We don't know. It's just you throw more and more nodes, and that means longer training, etc. But people are solving this problem by giving more resources. They are building more data centers, etc. And that progression is exponential. But the nature itself of the network, because it's a network, it's a power law. Power laws go one to one with networks. Anyway, let's see what is the next question. This is a very cool question, and in fact, I do address it in the book. He didn't know. He didn't know. That is the beauty of it. He just thought, okay, what could be the good properties of money, of digital money, right? And he started to come up with all these components like a fixed supply. It needs to be decentralized. It needs to be this. It needs to be that. Introduce the idea of the difficulty adjustment, with basically is kind of like a feedback loop to regulate the system. That is, I think, is a central component. It's not studied well. We need to study actually what is the role of a difficulty adjustment in keeping the system scale invariant. I think it's a very important component of the recipe. But he didn't think oh, I'm going to create something that looks like cities, something that looks like earthquakes. He didn't. That is the beauty of it. It is an emergent property. So he had all the right ingredients. And when you go back, when they say, oh, these
Yeah,
ingredients are supportive of something that eventually will look like scale invariant and look like a power law, but he didn't think that way. You know, but it's cool
here's
that yeah. Go ahead.
yeah.
Go ahead.
Satoshi in Japanese means wisdom. Here's what Satoshi knew and wanted to do. He wanted to create something that defined itself and did not depend on any external authority. That means Bitcoin creates its own coinage, it mints itself, it creates its own security, it creates its own ledger, its decentralized triple entry ledger. It creates its own control mechanism for the minting so that the network stays coherent and that everything's a block, 10-minute block. The difficulty component is a very important component of the algorithm. It creates its own defined, absolutely finite supply with the halving schedule. It creates its own assay. It is all self-defining structure at that level, similar to what happens in a cell. Cells have walls, they have boundaries, they take in resources, and then they create the structure internally with DNA and messenger RNA and the creation of proteins and structures within the cell. And Bitcoin is analogous to that. It's autopoietic, which means it's self-creating, self-organizing, self-maintaining. And once you do all these things, you have the potential to create continuous scale invariance, and the natural expression of that is a power law. Now, you have to reach a certain scale, as Giovanni has just said. You have to, and the network get to a certain level. It's got to kind of bootstrap itself and go through a process because it has to attract humans. It has to attract the miners to mine it. It has to attract the full nodes to hold the ledger, humans. It has to attract the energy, the computational rigs to power the miners. It has to attract the ability to buy and sell the asset and the networks to get created. That all gets created exogenously by humans. But the potential is there. It's autopoietic in a way that you do not have even with the gold system, where all of these capabilities in terms of minting a coin, first refining the metal, assaying it, minting the coin, and then creating the ledger and the security, that's all external to gold. That's all done by humans. So it is not autopoietic. So it's called allopoietic. External influences create and define it. Yeah. So when you have those, you have the potential for the scale invariance and power law.
Many artists, many engineers, many scientists, like for example, Galileo didn't have any clue that by coming up with a very precise way of observing nature, right? Okay, follow this, what we call the scientific method. Few hundred years later, we will go to the moon that he was observing with the telescope, right? It's one of these things where you got the right approach, you got the right intuition, and then nature, as gifts for you, right? When you are on the right path, nature tells you, right? Okay, you are on the right path. These are the consequences of that, right? These all the benefits that you get out of that. So, he created a new world for us that we're living right now, where all these benefits of modern civilization, of science and technology. Same thing with Satoshi. He had a very strong intuition about what made good money, what made sense in terms of exchanging value between people, and then under the right conditions, the collective wisdom of humanity and nature in general, right, is self-organizing systems that Stephen has founded this beautiful language. In fact, one of the things I need to add is actually a reference to Stephen's idea of auto creation, self creation, because I'm insisting in self organization, but it's even more powerful than that. Self organization is one thing, self creation is even deeper, because actually, uh, Bitcoin started from nothing, so it's actually a process that actually self-generated in a certain sense. Um, so yeah, it's a great, powerful vision, and this is why I insist, right? Because look, it's not that we are trying to make this grandiose claim. There are two possibilities. Or what we are saying, all the things that we are telling you are true, or they are not. Okay, and if they are not, if they are true, this is the most profound, most deep way of understanding Bitcoin. And not just that, is also the most true. Okay, it has the most information, it has the most knowledge, and in fact, the most alpha. If you want to use it to make your decision, for the future and trying to understand where Bitcoin is going as an investment, as a style of life, because many people even change their way of thinking about the world using Bitcoin. So it's a powerful thing, and I know that some people resist it for many different reasons, or maybe they don't see the big deal of it. But you know, this is why I'm writing the book, and this is why we continue to do this show, and we want to educate people. And so this kind of goes to this comment. Yeah, look, everybody comes to this with whatever they understand, right? And it's already great because you are doing an effort. You're looking at the show. You're trying to make sense of it. I invite you again. It's not because I want everybody to buy my book, even if I spend a lot of time. And yes, I would like that. But read the book, because the book hopefully gives you some basis. It talks about the network theory. It talks about a self-organizing system. It talks about it's supposed to give you all the basics for what the math is there. I don't want to say unfortunately, because it's actually the beauty of it. It's not very difficult math, right? And I'm not saying this for by trying to be dismissive and say, oh, you don't know basic math, but I try to almost do the opposite. It's You can understand it, believe me. If you spend a little bit of time, you're trying to understand how it works. And with AI today, it's so easy. Use AI. Try to say, look, can you explain it to me? Don't say, the only thing I ask you, don't tell them that is an American thing. I don't know why Americans do it. Do it like if I was 5 years old. You are not 5 years old. You are an adult. Do it, explain it in simple terms. So give me, see, for example, was this famous physicist, Feynman, and he had this saying where you can learn basically anything if you break it in small steps. Any most difficult concept, you can break it in small steps, and then you can understand it. So I'm saying the opposite. You are all of you, in particular because you are Bitcoiners, so you show already some level of discrimination in intelligence. You can do it. So ask ChatGPT to break down the concept one by one. Gives you some examples. It will take you some time, but it's worthwhile, because then you will have a different understanding about Bitcoin that is much deeper, and also it's very useful to understand many other things in life. For example, I just show you that you could understand better AI. For example, the challenges of building different models of AI, understanding the scaling law. They come up everywhere around us. So if you ask ChatGPT to give you some mini lessons, about what the power law represents, give you some example, showing you some. I'm sure of it. He will do a great job, and you can learn fast. Everybody does this at their own pace. The holographic principle. I'm sure there are some analogies. The strongest one that I can think is that the holographic principle says basically every piece of nature contains all the information about everything else. Like if you really try to simplify, and Bitcoin in a sense is that, because you could take a small chunk of Bitcoin. The problem is that there is noise. So if you don't, if that chunk is not big enough, you will be confused by noise. But if you look at, I will say even so, probably the biggest, smallest chunk is at least 4 years. Now, with my method of looking at the slope, you don't even need that, right? For example, you can see my method of the slopes, you could have taken even 1 year or even 6 months and see these oscillations around this n and see the system contains everything that needs to be known that you could extract the, for example, you could extract the distribution of the gains and then use that information to do a Monte Carlo simulation, and it will give you all the possible way that Bitcoin can grow. But then the median of all these possible way is the power law. So in a sense, yes, like you can take a small chunk of Bitcoin and get all the information you need to reproduce Bitcoin history. That is actually, I didn't think about that. It's a pretty good analogy. I like it. Bitcoin contain all the information about Bitcoin in a small chunk of itself. It's kind of true. What do you think about that, Stephen? Stephen? I don't know if Stephen can hear us. He's having some problem of connection. Anyway, guys, yeah, it's actually something to think about. It's pretty cool. All right, guys, I think we covered a lot of material. We are going for almost 2 hours now, so we can actually conclude here. All right. We will see each other next week. Thank you, guys.